It's a true crime podcast with two friends
I'm Ford.
And I'm Vegas.
who hate each other.
The only if I fell down the stairs, the only reason I would die is because I had a heart attack. That's the only reason.
One could hope.
Yeah, you wish.
Truly, a true crime podcast for the ages.
She is an Oklahoma grandmother, and she's facing a murder charge after her 3-year-old granddaughter was found dead in a trash can like a prom night baby.
A true crime podcast that tells it like it is.
Allegedly.
Well, it's obvious.
No, but it's
obvious. It could still be allegedly.
But yeah, but you have
But
to
it's
say-
obvious that he did it.
Well, no, it's allegedly.
It's allegedly obvious.
No.
Ford and Vegas, a true crime podcast for the ages with two friends who hate each other. It happens weekly on YouTube and wherever you get your podcasts.
Don't forget to hit the subscribe button.
I don't often make a big deal out of the podcast that I promote in the beginning of the show, but I'm addicted to this one. It's called Smoke-Filled Rooms. Gregory does an excellent job with his show. I'm absolutely hooked. If you like historical politics mixed with a dash of corruption and true crime, this is your gig. Give a listen to Smoke-Filled Rooms.
Hello everyone, my name is Gregory Zink, and I'd like to welcome you to my political true crime podcast called Smoke-Filled Rooms. With my background in political science, I present deep dive storytelling shows that focus on history's most infamous governments, leaders, parties, policies, and discontents. For at the core of society's dysfunctions are the criminal powers that lord over us, and the attempts by competing interests to strike back at the system. So grab a couple cigars and meet me behind the Capitol building for bi-weekly episodes featuring the political realm's most diabolical. The Smoke-Filled Rooms podcast is a member of the Darkcast Network and is available wherever you get your podcasts. And make sure to visit smokefilledrooms.net to sign up for my mailing list. Listener discretion is advised for topics including violence, coarse language, substance use, sex, and disturbing situations. We'll see you soon.
Darkcast Network. Come on over to the dark side. We're really nice people once you get past the true crime and scary science. Hello, and welcome to Cause of Death, 100 Seconds to Midnight. I'm your host, Jackie Morant. I'm hoping you all made it through the holidays safe and sound and without food poisoning. I might be too late to save you from that food poisoning this holiday season, but at least I can tell you that you probably won't die. At least not if you have the common run-of-the-mill E. coli infection. I'm going to talk about 0157 and some other more pathogenic E. coli strains in a future episode. 0157 deserves some special attention. And here's my shameless plug for all of you to rate, review, subscribe, and share these episodes. Seriously, share. I'm really not as geeky as the beginning of the show makes me out to be. There are some really interesting episodes on Patreon and Apple subscriptions, so if you want to hear what's on my mind, that's the place to be. My last one was on how failure supports success in research. I think it's pretty good. Join up and give a listen. The links to join up are in the show notes. I'm still deciding on this month's bonus, but I did put some extra bonus content up. There is another conversation over beers with Eric Carter-Lundeen of True Consequences podcast. This one is a little less intense than usual. I asked you all to vote on next season, and wildlife diseases won that poll. So, season 6 will be all about wildlife conservation and the diseases that affect animals in the wild. There will also be a couple of 100 Seconds to Midnight episodes sprinkled in there having to do with wildlife conservation and ecosystems. A close second in that race was a season of 100 Seconds to Midnight episodes. 4 of those back to back. That is going to be season 7. So get ready for that. I also wanted to tell you that I was interviewed for Voyage Ohio magazine. That was a lot of fun. If you want to take a look at that, the link is in the show notes. And on to the last bit of business. The Bulletin of Atomic Scientists will reset the doomsday clock on January 24th. This year, the announcement will be made in Ukrainian and Russian as well as English. It sounds like I might have to change the name of the show to 30 Seconds to Midnight. The topic of my show in 2 weeks will be the follow-up on the announcement, the concerns for this year, and the time left until doomsday. It'll be an interesting chat, I'm sure. I might try to watch the live stream at work, but don't tell anyone. I'll give the rest of my shameless plugs at the end of the episode. Let's begin with etiology and pathology. Escherichia coli is the most intensively studied and best understood organism on the planet. It's easy to handle, it's a hardy little germ, and it's versatile. It's used as a model in many antibiotic studies. Recent studies have found that wild E. coli has a distinct presence in the environment. It's also a normal flora in the gut. E. coli is kind of your run-of-the-mill bacillus. It's a gram-negative facultative anaerobe in the family Enterobacteriaceae and is closely related to some other bacteria that we'll talk about later, such as Salmonella, Klebsiella, Serratia, and of course we've already talked about Yersinia pestis. It grows happily at a temperature of around 38 Celsius, but it doesn't handle temperature fluctuations or changes in pH very well. It won't degrade pollutants or photosynthesize. It will, however, degrade lactose. While it is found mostly in gut microbiomes of mammals, it can also be seen in the gut microbiomes of birds, reptiles, and fish, as well as being found in soil, water, plants, and food. It lives in the lower intestine of most mammals. E. coli commonly makes up about 0.1 to 5% of the total microbiome of the normal flora of the gut, with its niche being the mucous membranes that line the gut. Basically, the normal flora of the gut helps digest food. Without it, bad things happen. The host organism regulates normal E. coli through immunoglobulin A. IgA helps facilitate the formation of E. coli biofilms on the intestinal mucosa. E. coli seems to have a mutualistic relationship with its host. It produces vitamin K and B12, and both of these are required for mammals to remain healthy. E. coli also keeps the gut a safe place for anaerobes that live there by consuming oxygen. Most importantly, E. coli keeps invaders out. It will fight off other bacteria that threatens to invade its domain in the mucosa. This relationship begins at birth. As a baby is born, it is inoculated with E. coli from the mother's fecal matter and from handling immediately after the child is born. E. coli becomes more abundant in the mother's microbiome during pregnancy, thus increasing the chances of her newborn being exposed. The colonizing strains have secretion systems and pili that allow them to attach to and interact with the infant's gut epithelium. Children who are born by cesarean section don't get this advantage, and it's found that they have a higher rate of colonization by Staphylococcus aureus. Staph aureus has been linked to an increased risk of developing a variety of disorders, including asthma, obesity, and diabetes. So, long story short, keep your good gut flora intact. E. coli is constantly being shed by mammals through their feces, and it has adapted to the harsher life outside of the perfect environment of the gut, at least long enough to make it back to a host. Some E. coli strains can survive fairly well outside of the host and will establish themselves as part of the soil, water, and plant communities. There are strains of E. coli that have adapted perfectly well to the outside world. Now, don't go out and start eating dirt. Normal flora is one thing, but But when that normal flora explodes into an overwhelming population, that is a completely different matter. E. coli is the cause of diarrheal diseases, peritonitis, colitis, bacteremia, infant mortality, and urinary tract infections that kill about 2 million people every year. So how does that happen? Well, if E. coli is introduced to an organism outside of the lower intestine, it no longer has that mutual relationship with the host. Rather, it makes itself at home and wreaks havoc. There are also pathogenic strains of E. coli. These strains include enteroaggregative, enterohemorrhagic, enteropathogenic, enterotoxigenic, uropathogenic, meningitis-associated, and septicemic-associated strains. I'm going to give a quick rundown of the different serotypes of E. coli so that you can get an idea about who's who at the zoo here. This is a very short introduction. I could actually do a whole season on E. coli alone. Enteropathogenic E. coli is also known as EPEC. EPEC. This was the first pathotype of E. coli to be identified back in 1945. Researchers in the UK took samples from children who were healthy and children who were presenting with severe diarrhea. The team found that different strains of E. coli were present in these children. EPEC attaches to the intestinal epithelial cells, causing some pretty intense cytoskeletal changes. The microvilli of the intestine are effaced, and the pedestals that the bacteria usually camp out on will rise up from the epithelial cells. A particular gene causes this to happen. That gene is called the locus of enterocyte effacement, or LE. This particular locus is found in other pathogens as well. We'll get to that later. Trust me, we'll be talking about it. Enterohemorrhagic E. coli, or EHEC, EHEC, was the first recognized as a cause of human disease in 1982. EHEC causes bloody diarrhea, non-bloody diarrhea, and hemolytic uremic syndrome. EHEC hangs out in the intestines of cattle. 0157 belongs to the EHEC family of pathogenic E. coli. I'll get into this a lot deeper in the one-hit wonders, but the key virulence factor for EHEC is STX, or virocytotoxin STX. STX is produced in the colon, then travels through the bloodstream to the kidney where it causes renal failure. Shigella toxin also exists in several other diseases that are, well, mostly fatal. Enterotoxigenic E. coli, or ETEC, ETEC, causes watery diarrhea and stomach cramps that range from a mild self-limiting thing to a purging, end up on fluids to replace all the fluids you lost kind of thing. This is the cause of most childhood diarrhea around the world and is certainly the main cause of traveler's disease worldwide. This is also the one that you normally get when you think you have the, quote, 24-hour flu. ETEC invades the small bowel mucosa and proliferates enterotoxins, giving rise to the intestinal secretion. Fibrillar colonization factors mediate the colonization of the bacteria in the small bowel. These colonization factors are antigenically diverse. As many as 20 different variations exist. ETEC produces enterotoxins, which belong to one of two groups: heat-liable enterotoxins or heat-stable enterotoxins. And each ETEC strain can have either heat-liable, heat-stable, or sometimes both. Enteroaggregative E. coli, or EAEC, is the pathogen that can cause mild long-term damage to the intestinal wall, causing often persistent diarrhea. EAEC colonizes the intestinal mucosas and secretes enterotoxins and cytotoxins. And then the bacteria will adhere to one another and form a stacked brick configuration. The bacteria will attach to HEP2 cells and intestinal mucosas by fimbrial structures known as aggregative adherence fimbriae, or AAFs. Enteroinvasive E. coli, or EIEC, are very closely related to Shigella species. At the species level, they're indistinguishable, but when you look a little deeper, they're different enough that the nomenclature remains. EIEC may cause an invasive inflammatory colitis with blood and mucus in the stools. It occasionally causes dysentery, but in most cases, you pretty much get watery diarrhea that's pretty much the same as other E. coli pathogens. EIEC will invade the epithelial cells of the gut, then lyse the endocytic vacuole, multiply intercellularly, move through the cytoplasm, then the adjacent epithelial cells. It also induces apoptosis in infected macrophages, so they die while fighting the infection. This has been implicated as the cause of diarrheal infections in children under 12 months of age. Diffusely adherent E. coli, or DAEC, are defined by the presence of a diffuse pattern of adherence to HEP2 cells. About 75% of DAEC strains produce a fimbrial adhesin called F1845. These use DAF as a protein which normally protects cells from damage through the complement system. DAEC strains induce a cytopathic effect that is characterized by the development of long cellular extensions that wrap around the adherent bacteria. Then they all just hang on for the ride. It has been thought that DAEC could cause inflammatory bowel disease as a long-term morbidity. Uropathogenic E. coli, or UPEC, UPEC, invades the urinary tract and causes urinary tract infections. UPECs are from a small number of O serogroups and have phenotypes that are associated with cystitis and acute pyelonephritis in the normal urinary tract. This includes expression of P. fimbriae, hemolysin, aerobactin, serum resistance, and encapsulation. Likely, this infection will begin in the bowel and then move to the urinary tract through poor hygiene. Remember when they used to tell you to wipe from front to back, ladies? E. coli causes about 75% of UTIs. Meningitis sepsis-associated E. coli, or MNEC, is the most common cause of gram-negative neonatal meningitis. The mortality rate in this type of infection ranges from 15 to 40%, and the morbidity rate is almost 100% in the survivors of the disease. MNEC causes severe and irreparable neurological defects in those who manage to survive the illness to begin with. 80% of these pathogens are K1 capsule type, with a minority of O type sprinkled in for good measure. This strain of E. coli doesn't spread through the oral fecal transmission. It's bloodborne. High levels of bacteremia correlate with the development of meningitis. The bacteria can cross the blood-brain barrier and take up residency in the central nervous system. They do this without damaging the blood-brain barrier at all. Electron micrographs have shown that the bacteria can translocate from the blood through the central nervous system by employing a zippering mechanism that doesn't affect the transendothelial electrical resistance in the least. The host cell membrane is not disrupted during entry. Okay, I'm going to get all down and dirty with 0157 during the one-hit wonders, so I'll talk more crap during that season. You'll be horrified. You'll never eat an undercooked hamburger again. This gave a really short introduction to the genomes of some of the E. coli strains. yeah, there are more. It's a really fast mutator. So there are strains of E. coli for days and months and years of podcast episodes. Some of them are non-pathogenic and others are, well, highly pathogenic. And while I'll get pretty far into the genome of O157H7 when we get there, for now, I feel like I should explain how one little bacterium can cause 7 types of disease and still be normal flora. E. coli survives by genetic diversity. For instance, the K12 strain that's commonly used in labs as an escape pathogen, O157H7, and the uropathic strain CFT073 share about 39% of their genes. E. coli has a gene structure that contains roughly 16,000 genes, and many strains share less than 20% of them. Horizontal gene structure plays a huge role in the gene structure of the bacterium. Flexibility of the gene structure can be found in prophasias, transposable elements, and accessory genes. These genes encode for traits like improving the bacterium's health in certain environments, increasing or decreasing the bacterium's metabolism, and of course, pathogenicity. All this means is that E. coli mutates extremely quickly, and novel pathogens could arise from the mix and match gene structure that the bacterium has chosen as a survival technique. Symptoms of E. coli infection include bloody or watery diarrhea, abdominal cramps, possibly a low-grade fever, and possible vomiting. Let's not forget the common flu-like symptoms of headache and general malaise. If you find yourself with an E. coli infection, do not allow yourself to become dehydrated. If Pedialyte isn't getting it, get to a hospital. Patients die from dehydration. E. coli is really easy to avoid. It's super easy. Don't cut vegetables on the same cutting board you use for meat, especially if those veggies are going to be served raw. Cross-contamination is a thing, people. Wash fruits and vegetables before you cut them or eat them. I don't care if the package says they've been washed. Wash them again. Cook your meat all the way through. In roasts, an internal temperature of 145 degrees Fahrenheit is acceptable, but let the meat rest for at least 3 minutes after you remove it from the grill or the stove. Ground beef, chicken, and pork should be consistently measured at a minimum internal temperature of 160 degrees Fahrenheit. Avoid raw milk, unpasteurized dairy products, and unpasteurized juices. Don't drink out of streams, lakes, rivers, or swimming pools. Most importantly, wash your hands. I still can't believe that I have to tell people to do this. Wash them often with soap and warm water. Scrubby, scrubby, my friends. Now it's time for me to give you what you came for. The story. The late 1800s were a time of microbiological development. In 1861, Pasteur disproved the spontaneous generation of life theory. In 1917, Deherel coined the term bacteriophages. These are viruses that invade bacteria. Many different bacterial species were found and identified as pathogens that could infect animals and humans alike. Louis Pasteur, Robert Koch, Joseph Lister, Albert Neisser, Friedrich Loeffler, Carl Joseph Eberth, David Bruce, Alexander Yersin, Shibasa Buro Kitasoto, and Paul Ehrlich were all living in the golden age of microbiology. These men put all their efforts into finding pathogens and subsequently curing the diseases they caused. However, there were other microbiologists and immunologists that were studying mutualistic interactions between microbes and their hosts. Theodore Esserich and L. Metchnikoff were delving into the non-pathogenic microbes that were naturally in the body. These were called normal flora. Escherich and Metchnikoff wanted to know if there were certain organisms that could be more beneficial to a host, and they wanted to do a deep dive into the coexistence of the bacteria in the gut and figure out how it was regulated. They particularly wanted to study the interactions between the bacteria with other bacteria and the bacteria with the host. Alfred Niesel had been working since 1912 as a first medical assistant in hygiene and bacteriology at the Hygiene Institute of the Albert Ludwig University of Freiburg, Germany. From 1915 until 1938, Niesel was head of the Baden Medicinal Investigations Office for Infectious Diseases in southwest Germany. By 1938, Niesel had left the Hygiene Institute and opened his own private laboratory in Freiburg, where he did research until his death in 1965. During the early 1900s, when medical students were studying microbiology, one of their assignments would be to take human feces and plate it to see what grew. Most of these samples would have pathogenic salmonella added. Niesel found that salmonella would grow out of the lawn of other bacteria, but in some cases, salmonella would either grow poorly or sometimes not at all. In those cases, E. coli would be the most prevalent. Niesel began to postulate that E. coli could prohibit the growth of other pathogenic organisms. In this case, he was thinking salmonella. He began working on research, and he was successful in proving that certain strains of E. coli taken from healthy people could prohibit the growth of salmonella and other enteropathogens. Niesel called this phenomenon antagonistic activity. He proceeded to create an antagonistic index based on quantitative assays that he called the antagonistic test. From this, he gleaned which strains of E. coli were antagonistically strong and which were antagonistically weak. Niesel 1917 was a strain of E. coli that Niesel had isolated from a German soldier during World War I. This man was in a field hospital near Freiburg, but had been in the Balkans before this. He had been on deployment in the Dobrudja region for some time. This region had seen major outbreaks of Shigella, but this man had never experienced illness. Niesel took stool samples from this man and isolated the normal E. coli from them. The E. coli from this soldier showed strong antagonistic activity against many different pathogens. Remember, this was in the years BA, before antibiotics. So Niesel didn't move forward with his research to find which biochemical substances were responsible for the effect. He was more interested in seeing if E. coli could actually treat gastrointestinal disease caused by other pathogenic bacteria. He presented his research on June 20th, 1916, in front of the Freiburg Medical Association. His lecture was called On the Fundamentals for a Novel Causal Control of Pathological Gut Flora. The lecture was also published in the Deutsche Medische Wissenschaft. This work was the springboard for others who wanted to study the ways that normal flora could be used as a prophylaxis and therapy. With the advent of antibiotic therapy, research in treatment options using antagonistic bacteria declined. However, over the last 20 years, antibiotic resistance has been steadily increasing, so interest in an alternative biochemistry has grown. It's important to note that the gold standard antibiotics that we use today also have their basis in nature. Penicillin comes from mold. Doxycycline comes from a plant. You get the picture. Most drugs are like this. Neasel 1917 is still in use today. It's called Mutaflora. Today, we call it a probiotic. Probiotics are used to stimulate the growth of normal flora. If you've ever had to take a heavy dose of antibiotics to knock out a bacterial infection, you've probably been encouraged to take a probiotic. Mutaflora may have even been prescribed for you by your doctor. Okay, so that's the short version of E. coli. The next episode will be a 100 Seconds to Midnight episode on the movement of the Doomsday Clock. This year's message could be the most important one in the recent history of the Doomsday Clock. Don't forget to rate and review the show wherever you get your podcasts. Most importantly, share with everyone you know. Thank you for listening, and I'll see you in 2 weeks when we'll explore the Doomsday Clock and the message we have for this year.